A couple quick things about me. Got an MCSE going back to the NT4 days, all the way up to present. Also an Azure Cloud Architect and MCT. Um, I've been doing this IT stuff for a little over 20 years, so just been enjoying it. Been able to have the opportunity to work with Azure over the past almost decade now. Um, been enjoying the IT security and infrastructure aspects of it. If you have any questions after this or any other time, feel free to reach out to me on LinkedIn or Twitter, just Azure SMFX or Small Fox on LinkedIn. And feel free to reach out if you have any questions. All right. In today's sessions, we're going to have a brief overview of the Azure Firewall and how it relates to security in Azure. We're going to start with a very small coverage of the network overview generally in Azure, where the Azure Firewall goes into it. And then we're going to dive into the Azure Firewall and features, how you would utilize it. We're also going to be talking about the recently released the Firewall Manager. That's with Azure and its common scenarios. And finally, time permitting, we're going to be doing a quick live demo of managing the firewall and how you can utilize it in your environments. At the end of the session, we'll have a focused Q&A, but if you have any questions at all during the session, please feel free to bring them up in the chat or send me a note. Let's see if I restart this. All right. Back to the agenda now. Again, we're going to be talking about the Azure Firewall. Going to go into general networking first. Going to be focusing then on the Azure Firewall and how it works within Azure and its networking pieces, and the Firewall Manager, which was a recent service released by Azure, and how you can utilize it in common scenarios. And then finally, again, time permitting, we'll be talking about the demo. At the end, we'll have the focused Q&A section for any questions. But if you have any questions between now and then, please feel free to bring them up at any time. Just bring them up in the chat or raise your hand. Okay. All right. Well, without further ado, let's go ahead and start with the Azure Networking. So, at its core, all private networking in Azure is based around virtual networks from VNets. This is the basic method of how resources and services can be segmented. It's on the concept of VLANs that you have on premise. They define your address, IP address spaces, as well as separate out into individual subnets. Also, resources such as VMs are tied to a VNet upon creation. They can't be moved, and without actually destroying that VNet or VM and then recreating it. You can move between subnets within a VNet all you want, but that VM, once you create it, it's tied to that VNet. So it's a very core function of the network in Azure. They can be peered directly to each other. So even across regions or subscriptions, you can have just a straight communication private between two VNets just by doing simple peering setup. All addresses in Azure by default are dynamic. You can reserve those addresses, but the operating systems usually still see it as a dynamic address. You can configure them once you've reserved it and actually do a static addressing, but with the software-defined networking principles in Azure, it's usually best if you can leave your host just to think that they're using DHCP and just to do all your IP management within Azure itself. And the VNet allows you to do all those settings that way. By default, VNets themselves do not limit any communications. Once you have something attached to the VNet, if there's another resource attached to that VNet, they can talk and communicate directly, and there would be no restrictions. However, the network security groups was the base level that was brought in to address those types of needs. It's a classic allow, deny tuple, where basically you have your source address, subnet mask, and port, and then your destination subnet mask and port. And that just defines what the rules are. They're very classic to the version rules that you'd see in original firewalls, switches, that type of thing. It's very basic rules. It also defines either the rules an inbound rule or it's an outbound rule. It's a good basic way for doing a lot of the filtering, but it doesn't give you any stateful inspections. It's doing pure stateless communications, and they're assigned to either subnets or NICs. But they're the core basic function of doing address filtering. If you don't have anything like that on your VNet, it's just going to be wide open. So the NSGs at least provide you basic functionality to doing restrictions. And then you have your public addresses. Anything in Azure, pretty much, that is going to be accessed from the internet is going to have a public IP address associated with it. And with these three core pieces, you could set up a website on a VM in Azure, and it would basically just be a very basic IIS website. Obviously, there's a lot of concerns about having a VM directly on the internet, but that is at its core what you could use to get a public site up and going, just with those three pieces. Then, just to kind of give an idea of where things have evolved from, there's a lot of edge services in Azure that deal around the internet and Azure services. These are the three common ones that would be involved. You have your application gateway that's providing your HTTP layer 7 load balancing, as well as routing. It's also doing TLS security and has the ability to do web application firewall. It can provide essential HTTP network security on your systems. It can be backended either by virtual machines or a URL address. It can even be an external URL. It doesn't even have to be something on Azure. But the app gateway is basically, that's what it's doing, is doing HTTP load balancing and routing based on the URLs. Then on top of that, you have your content delivery network, or as actually an additional service, not really on top. It can be utilized to ensure that your traffic is optimal for your clients. Basically, the idea being is that you have a point of presence out there that's doing cache content. For anything that's relatively static, anything that's dynamic, your client's doing a request to that point of presence that's local to them, and that's going across the Azure backbone to get to something in the back end. That's kind of what your CDN is. And then you have your front door, which kind of combines the services of those two. It's not a true application gateway CDN hybrid. No, it was a full service that was evolved by just those same types of services, but it's all in one pane, all in one management aspect of it. You can do URL rewrites. You can specify what type of routing structure you want to do. It was actually the service that Microsoft was using for a lot of its pieces, and they just developed it into a public service. And that's what Front Door ended up being. Now these services, they deal with inbound internet traffic. That's all what they deal with, is inbound, really HTTP traffic. And that's all that they're focused on. So those were services that were somewhat useful. They do a lot of security and a lot of great pieces. But there was a big hole that a lot of partners were filling with virtual network appliances and third-party tools, and that was with the more stateful security. And that's where the Azure Firewall comes in. That's what our focus is going to be on today. It's a managed edge device. It is going to connect directly up to your VNets. The stateful services that it brings into it is actually looking at your packets, making sure it's adhering to the protocols that you're looking to expect it to follow. It's not going to just be, hey, does it match this IP and that IP and got the ports right? Okay, great, let's go. No, it's actually going to allow you to look at the protocols and make sure it actually follows those, so that you can make sure somebody's not trying to do some weird tunneling of protocols across it. You can make sure that there's not, somebody just changes the port just so they can get past your firewall, and that's actually following that protocol is what they're looking to do. And then the other thing is that since it's a managed service and it's built on top of Azure, it is immediately high available. Once you turn on Firewall, you don't have to set up any load balancing. You don't have to separate multiple instances. You don't have to figure out, is it in one availability zone or the other one? No, you just high availability from day one. You turn it on, it's highly available. You don't have to do anything else. The other nice thing is it also scales automatically. It's really based around the amount of data that you're putting through it, is basically how they do the charting. So therefore, as long as you're putting data through it, they will scale to whatever you need. Obviously within reason. If you're looking for a huge amount of data put with very low latency, you're going to possibly see some slowdown just because you're having an additional processor of your packet. So yes, you're going to have a little bit of slowdown, but that's only for the extreme edge of the environment. Pretty much everything in Azure you can put through the firewall and you will be able to deal with it. Obviously, the more traffic you put through it, the bigger your charge. So take it with a grain of salt. But it scales automatically. You don't have to configure anything to let it do that. It will just take the traffic and process it. It'll integrate with Azure Monitor, and therefore also it can translate that data over into Sentinel. So you can monitor your traffic and identify any potential problems that you see coming across, and those logs can also be brought into Sentinel, and you can use that to help do any forensics traffic, and look at any of the areas that are coming into it. And the other nice thing of the Azure Firewall is that things like the app gateway and CDNs and the front door, all that's usually based around the HTTP traffic, web traffic. But the Azure Firewall deals with anything from layer 3, which is your IP ports, all the way up to layer 7, which is your protocols, your applications. So you're talking about HTTP. So it'll look at the TCP, it'll look at the application pieces, it will look at all those different pieces, and you can do rules based around that. So you're not having to just rely on, like, the network security groups only deal with ports and the application gateway only deals with HTTP. No, this will do both, and that's really a core function of the firewall. And then a brethren feature of firewall, which we're going to go into a little bit, is the virtual WAN, where basically it combines your branch, your site-to-site VPNs, express routes, VNets, all into basically a centralized cloud managed service. Lets you organize everything into a regional hub, so that you can say, hey, everything that I know that wants to be talking here, we can just put this into this regional hub, and everything that's going to talk over here, put it into another regional hub. You don't have to worry about routing, your peering, anything like that. It all just, you put it in that hub, and it manages all that routing immediately for you. And allows you to integrate directly with the firewall using secure hubs. So it gives you a lot of those details and a lot of that built-in functionality straight out of the box, and it makes it even easier for you to manage these solutions. And then finally, there's the Firewall Manager. What the Firewall Manager is going to be doing is centralizing all your security management for your firewalls, making sure that you have everything in one pane of glass. You can see all your different resources and see all your different aspects of your firewalls throughout your entire environment. You can do it with just one subscription or multiple subscriptions. So this is a really great solution if you're in an enterprise and you're looking to deploy firewall across your enterprise, because it lets you set global policies for your environments and make sure that everybody's adhering to what's needed for your particular environments. And the policies that they subscribe to, they're going to immediately get anytime you update it. You just update in the firewall and it gets pushed down to all of them. And that also allows you to do local management of individual firewalls so that you can, obviously tier or actually customize it for each one of your different environments. That way you're assured that you get the centralized control in minimal standards of everybody, but you're also making sure that they have the ability to customize the individual pieces that are needed for their particular environment. It also lets you manage all your route settings and all of your controls that way in your centralized environment. That way you're assured that maybe your different environments don't suddenly have a rogue route table entry that is sending it around the firewalls. Make sure that everybody's continuing to do all the route management locally. So basically the Firewall Manager is, if you've ever dealt with a lot of the third-party tools that are out there, they would have a centralized piece that gives you one pane of glass, all the firewalls. This is Azure solution for doing that, rather than having 50 different firewalls and 20 different subscriptions doing multiple different environments. It gives you one central location you can go and manage those firewalls and have those policies controlled. Now, that's just a very short list of the network resources. This is just some more of the network resources that are out there. We're not going to dive into any of these. I just want to get a basic overview of everybody. You can look through this list. You can see additional ones. A lot of these will integrate with firewall in a different way, but just to let you know, those aren't just the only things in network and Azure. These are just a few of the additional ones that are out there. Not to mention, there's marketplace solutions from third parties that give you virtual network appliances and various other things in networking. It's a big, long list of things that are out there. It's not just what we've gone over so far. Now, I've touched a little bit on the traditional networking limitations that we talked about before. VNets intrinsically allow all traffic. The industries you can utilize to limit the traffic, but again, they're very specific on their rules as to which direction it's coming from, and also very specific IP ranges and ports. So it's not a full-fledged firewall. Is just a basic traffic limitation and traffic controls. You can also do application security groups to where you can have particular applications rather than specifying IP addresses. This really only works with virtual machines. It doesn't really do anything beyond that, and also it doesn't work outside of the individual VNet. But it's a good way to be able to, say, hey, this application is going to be allowed this way, and it works in your NSGs. And basically, it works similar to the classification tags that you may have seen in Azure for things like Traffic Manager or the Azure Monitoring Services. There are tags like that, Azure SQL Services. The application security groups basically give you that ability to do your own custom tags. But again, it only works within your virtual network and the single virtual network where it's at. And it's only really with VMs that you can utilize that. The NSGs are also stateless inspection of the traffic. It's not looking to see, is this in the middle of a transaction? Is this something where, we haven't really done all the handshake ahead of time and we've, not interrupting the middle of a session. We're actually doing a full-fledged session. So the stateless pieces of the NSG, it just, if it matches the IP and the ports, it's allowing it. Also, app gateways and front door, they're only looking at inbound traffic. They don't care anything about outbound. It's really just things for people to come into it. And then also, there was no real centralized management of rules across subscriptions. You set up an NSG in one location, and then if you want to set up another NSG in another location, you're going to have to go through the whole processing of those rules. There are obviously CI/CD type solutions you can do to more directly control those and kind of optimize that, and you can use scripting and automation, third-party tools to do it, but there's no real way in Azure to say, hey, I want this rule applied to all my NSGs without doing some policies or some automation pieces. But it's not even really something that you can come back and control and centrally see very well. It's no NSG centralized management or anything like that. So now I have kind of a foundation of the networking and just the understanding of what Azure is. Let's go ahead and start talking specifically about the firewall a little bit more in depth. So as with everything in Azure, firewall is structured around the shared responsibility model. In this particular case, it's actually falling within the PaaS space. That means platform as a service. So Azure manages all the instances, the underlying host, the availability, the scaling, all that configuration pieces, as far as the hardware and OS and scaling is all done by Microsoft and Azure. All the configuration, all the management, that's all done by the customer side. So any rules that you want to set up, anything like that, that's all configured by you. But Azure is making sure that's going to run and going to adhere and follow whatever rules you give it. You're also responsible for monitoring all those rules, making sure that it's following what you need. Obviously, Azure's not going to know that you want site A and site B to be able to talk, but not site C. They're not going to know what protocols you're expecting to work. So that is all up to the actual customer. Also, as far as monitoring the rules and making sure that there's not something that's coming up as an alert, not something that there's a particular problem with your traffic. That's, again, something that's the customer's responsibility. Azure's just going to make sure the firewall's working, making sure that if there's a problem with those pieces, that they're dealing with the underlying hardware, but the actual rules and stuff, that's obviously got to be monitored by you. So that's why you're implementing Azure Monitor, bringing in maybe something like Sentinel or SEIM to help you monitor the traffic is something else that's useful. So those are just a few of the pieces that fall under the paths. Okay, these are just a few of the features that the firewall has. As I mentioned before, in contrast to VNets and VNGs, that would allow all the traffic, firewalls by default are denying all the traffic. So therefore, they're security first mindset. Now, sometimes people are a little frustrated by this, because suddenly they put in an Azure firewall and all your traffic's been blocked. Well, that was by design. A firewall is not going to just have the any rule that's at the bottom of the NSGs that's going to allow traffic to suddenly work. The Azure firewalls are going to block everything. You have to tell it you want traffic across. Now you can generate your own rule and say, hey, allow anything for whatever protocol, and then put your denies above it. You can do something like that. But usually what's recommended is to identify what traffic you want to have happen, put those allow rules in, and then anything that you don't specify is going to be blocked. Sometimes this is a little bit difficult to work with some of your application vendors because they don't actually have clearly defined rules. So you may have to tweak it a little bit and kind of work towards things. But the idea behind it is that you want to make sure that your environment's secured. And so we're going to start with the security to begin with, and then we're going to move and allow only those pieces that we want to expect to have this traffic. That way you can make sure it's a much more controlled deployment. And obviously, we've talked about the high availability and scalability. Again, these are things that are built directly into Azure Firewall from the get-go. You don't have to do anything else. Once you've set it up and spun up, it's immediately high availability. It'll continue to grow as the load comes across it. You don't have to do anything to set those pieces up. It's going from day one. You can also configure the firewall to be within a specific availability zone. If you're not familiar with the availability zones, basically within each Azure region, which is a geographical location, there's usually zones. Some regions don't have zones clearly defined, but a lot of the bigger ones do have those zones already defined, and they're getting more and more common. The idea behind a zone is that within a geographical region, they'll have up to 3 zones within that region. And if you put your resources within a particular zone, you can optimize your latency to make sure it's as low as possible within resources in that zone. So you can generate an Azure Firewall, make sure it's in the zone that's very close to your resources, and therefore minimize the latency. We're talking into the millisecond difference here between the different zones. So this is a solution where you're dealing with very low latency is a big concern. A lot of people don't necessarily need the availability zone, but it's something that's there that if your solution requires it. But this is something that's only configured at the time that the Azure Firewall is created. You cannot come back and move it to another availability zone later. If you need to, you're just going to have to spin up a new Azure Firewall or in the new zone and deal with that. If you don't put in an availability zone, Azure deals with the availability as part of its high availability concern. So you don't have to worry about is it in zone 1 or zone 2, if zone 3 is going through maintenance. Azure Firewall is dealing with all that backend. You don't have to worry about that. Also, it gives you the ability to do fully qualified domain name filtering, which is the FQDN. So you don't necessarily have to just do things by IP addresses. If you want to block traffic to a particular URL, you can just put in whatever that FQDN is. So, like google.com or msn.com or whatever URL. So you don't have to find the IP addresses that would be backending that and then potentially blocking some other service because you're only knowing that IP or allowing some other service, even worse, because you have to, open up the entire subnets of a hosting environment, and then anything else in there is fair game. In this case, you can actually block by just URL. Again, this is both inbound and outbound traffic. So you're not talking about just the stuff that's coming into the environment. You can talk about what's going out. So this is a really great solution for somebody who's doing like a Windows Virtual Desktop. Is we're getting more and more remote services, and people are deploying Windows Virtual Desktops for people coming out to it. If you want to make sure that your clients are only going to the expected websites, you can implement Azure Firewall, and you can make sure that only those clients outbound are the ones that are doing as well. So that's the other big key piece that Azure Firewall is bringing into it. And then also with the FQDN traffic, you also have the traditional traffic rules. So you can identify based on protocols and based on what type of traffic, just traditional IP ports even, and it'll do the filtering as well. And in addition to the FQDN, you can also do, rather than just doing like sites, you can also do FQDN tags that Microsoft is doing. So for things like Windows Update services or with, I'm trying to remember, it's a pretty short list right now, but basically there's a few lists of FQDN. So if you have people that want to go out and rather than having to specify all the different variations of Windows Update, you can just say Windows Update for the FQDN tag is allowed, and anything that falls under that URL list is going to be allowed. And then also on top of that, you can also utilize the service tags like we talked about, the MSQN or excuse me, MS SQL Server tags, or the load balancer tag. You can have all those. All those are utilized by the firewall as well. Then another big feature is the threat intelligence, and the threat intelligence is basically it's the service that Azure is using to do all of its intelligence feed from all the other services, where anytime that they're seeing something that looks suspicious, anything that's looking like it's a particular problem, like there's somebody trying to hack into a particular service environment, they're going to flag that traffic immediately in their threat intelligence feed. And the threat intelligence is something that the Azure Firewall can then feed off of. So even if your site hasn't seen any particular problems, as long as it's maybe been identified somewhere in the Azure infrastructure across the entire global infrastructure, if they've identified it as a problem, you can subscribe to that and it'll block before they even try and attempt you. So you can go ahead and have it denied immediately. So anything that gets flagged by the global Microsoft Threat Intelligence feed is immediately blocked into your environment as well. Then also it can do natting, both inbound, outbound, whether outbound source natting or inbound destination natting. You can have multiple public IP addresses on the firewalls, not just one like you would do with application gateway. You can have multiple different IP addresses assigned to it. The Azure Monitor integration, you can do force tunneling so that if you have all your clients going through your Azure Firewall, and then you also want to make sure it's going through your on-premise equipment or your existing infrastructure, you can force all that across through the tunnel. And then also the industry certifications. It's already been certified on over 50 global certifications, and then 20 government certifications. And they're adding more as as the additional ones come out. They'll go through the security requirements, making sure they adhere to all those. They publish those on a regular basis. And so anytime that you have a particular audit, whether it be PCI, HIPAA, whatever, you can bring up the Azure Firewall certifications and say, look, this is certified, so you don't have to worry about that particular piece of it. Obviously, your rules are going to have to go through their own auditing, but the underlying technology is certified by most of the security environments. If you have particular security needs, just go look on that list and see if it's not there. If it's not there, you can reach out to Azure support, see if maybe this is something they're working on, and maybe just be something that they haven't gotten to. If it is something that's maybe a little bit higher security, maybe you have to look at a third-party VNA for something like that, virtual network appliance. But for a lot of the environments, Azure Firewall will work. All right, so that's just some of the features in Azure. For the Azure deployment, there's really under 3 ways that we fall into this. You have your single VNet. These are really great for just a small environment. If you're a small organization, you just got a single VNet out there, you want to do some quick development testing. That's basically what you use, a single VNet. But it's only for the stuff on that VNet. What's usually a better model in most environments is going to be any region, any decent size, is a hub VNet for your firewall. In those particular environments, what you're going to be looking at is that you have your central hub for your region, and then you peer your VNets over to that, and they basically become spokes off of that hub VNet. Then they can route their traffic to that firewall. The nice thing about this is that, one, it gives you a central point where you can do all your management and do your controls for that particular region. You can also then utilize the firewall to secure the traffic between the different VNets as well. Because keep in mind, usually if you have a single VNet and you have your subnets within that VNet, they're not really going through the firewall usually. Usually you having your subnets talk directly. They're just going out through the firewall to get to the internet. Again, it's just one of those latency type of aspects of it. If you have an application that's expecting to do SQL queries right next to each other, you may not want to have the additional latency, and so a lot of times you don't have them route through the firewall. And then on top of it, if you have something on the local subnet, it's not going to talk across the router, so it's never going to hit the firewall. So those types of things, you wouldn't have the restrictions. That's where you use the NSGs usually if you want to do that. Now, that's not stateful pieces, but those are usually managed solutions that you have. So that's why you have that security. But if you have something like a DMZ where you have resources they're accessing, from the outside world, you can have that come into a VNet, and you can have your DMZ VNet come into it, have that peer to your hub, and then that traffic has to be routed through the firewall in order to get to your other environments. You make sure that nobody's going to be able to misconfigure it to where they can somehow have a route segment that lets them get around your firewall. You make sure that all that traffic has to go through that hub, that VNet, in order to get across, and to go through that VNet, it's got to go through the firewall. So that's a easy way to make sure that all that traffic is very well secured and configured. So this is why it's usually recommended to have your hub VNets. And obviously, if you have different applications, that shouldn't be talking anyways, but you want to be able to utilize the Azure Firewall. You can have them come into it. And then again, the firewall doesn't allow that traffic unless you tell it it's going to be allowed. So if you have multiple different applications come in, that's fine. The Azure Firewall is not going to allow that traffic across anyways, as long as you don't configure it to do that. So it's usually very safe to do that for most environments. Yeah. And so that's generally the hub VNet, and that's just the classic way to do it. The other way is what we've talked about is the a little bit the virtual WAN, and that's the secure virtual hub. And the idea behind it is that the virtual WAN is, again, one of those technologies that Azure's introduced to try and minimize the management headaches that you have with setting up all your VNets. Have you ever gone into an environment where you've had 20 VNets, and you had to have this one peered over to this one, and the other one over here, and this peer and this peer? You end up having to do all these different peers to all these different VNets, and you're having to try and manage it and visualize it. What a virtual WAN allows you to do is that you basically say, okay, I'm going to have a hub for this region. I'm going to connect the VNets up here for production and to this hub, and then therefore all those VNets can talk intrinsically, and then I can set up an Azure Firewall in that hub and make a secured virtual hub that they go through. And so now all the firewall rules have to pass across it. And this is a way that it gives you a very easy to manage centralized view for your virtual WAN in your virtual hub that makes it very easy to manage. It sometimes is a little disconcerting for a manager or an engineer that is suddenly used to seeing specific IP addresses, setting up the virtual VPNs across it, and you're basically handing that over to the virtual WAN to deal with those pieces. But it makes it very easy, and it takes care of all those pieces for you. You can also, with a virtual WAN, bring in your VPN connections, your branch connections to your different offices. Your express route can come into your virtual WAN. So you can, again, although that traffic can go through the Azure Firewall as well before it gets distributed and disseminated into your internal virtual network. It becomes a very secured, easy to manage solution that's enabled with a few clicks. And it's, again, secured by default. You're only allowing those rules in that you have it. You can then centrally control and observe it with the Firewall Manager. So if you have multiple virtual WANs with virtual hubs across different regions, different countries, you can have all that managed through your Firewall Manager. All right. So now there are some limitations to the firewalls. I mentioned a couple of them. For one, the Internet VNet, it's not really designed to do subnet to subnet filtering. You can configure it to do that, but it's definitely not designed for anything within a subnet. You can do NSGs to make sure the traffic is limited on the NICs, but you want to make sure that you're not really designing the firewall or expecting it to be, the only solution within a subnet communications. Two devices in the same subnet are going to be able to talk to each other, unless you put something like an NSG on them that's going to block that traffic. The FQDNs right now, they have to be specified to specific rules. You can't really set up an FQDN rule that is going to say any port. So you're having to set up things like HTTP, HTTPS, and you can put multiple ports, multiple protocols into those FQDN rules, but you can't just say any rule, any protocol. And it's actually kind of better that way, but that is one of those things that's out there. Also, firewalls, they're not portable. You're not going to be able to set up an Azure firewall in a resource group and then be able to move it to another resource group, another subscription. They are tied very tightly to their resource group. So this is something that is if you've been in a lot of our courses before, we've talked about is that the governance design ahead of time. You want to make sure that you are not only having good naming standard, but you also have a good resource group structure and good subscription structure, so that you have a clearly defined setup. Because if you find out later on, 6 months down the road, the naming standard doesn't make sense, your resource group's gotten cluttered, just some problem along that, you want to move over to another subscription. If you want to do that with a firewall, you're basically going to have to spin up a new firewall and export and import your rules across. It's not the end of the world. It's not, a horrible process, but it's not something where you can just, change the back end and let it move across. A lot of times people can move things like virtual machines or web apps between subscriptions even. You can't do that with firewall. You can't even move between resource groups. It's very tightly ingrained in its structure and its identity. So you got to make sure you're planning well ahead of time what you're going to have your standards. The destination net's really only for internal traffic. It is not intended, or excuse me, DNets, destination nets are only for internet traffic coming in from the internet. It is not designed for doing internal communication. So if you have a private spoke to another private spoke, you aren't going to be natting that traffic. Again, that's just one of the design concepts. You don't expect to have your nets internally, or your nets internal with the firewall right now. Once you create a firewall, the original IP is locked to it. So a lot of times it's recommended that original IP that you set up for is really kind of more for your management, or if you know it's going to be a small setup, it's really only used for very few key services. If you want to start doing your hosting through the firewall, which is a good process, you probably want to set up at least a second IP or even a third or fourth. The idea being is that if you ever want to switch services and want to move away from using the existing IP address for whatever reason, you have the ability to eventually scale it out and get rid of it. So if you can think about the IP that comes with it as kind of the original management IP, kind of think about that originally when you're setting it up and designing your firewall. It's not a horrible thing. It just means that later on down the road, if you want to reuse that IP address for some other service, for instance, if you're hosting a website on that IP and you were doing a natting from that, and then later on you decide, okay, we're not going to do it this way, and you switch over to using another IP, and if you want to reuse that original IP, now you have a bunch of traffic coming in hitting it that should have been hitting in the first place. So that's something to be thinking about. And then the threat intelligence, it's really just when you enable it, it's either alert, and deny. There is no real detailed information that you can get down to and say, well, I only want this level of threat happening, or I only want to have this level be alerted and then this level be denied, or I want to be anything that's geographically outside of my country. I want to have that initially be the higher threat denies, but I want to make sure everything within my geographic sphere is allowed. It's really just either it's either alert or deny. There is no fine grained tuning on it. It's just one or the other. It's a very binary setup. But keep in mind, the only thing that shows up in threat intelligence feed is when they've been seeing nefarious traffic of some kind in some space in Azure, and so therefore it's shown up in the feed and it's being blocked. But with any service that's going to block it, you want to make sure that you go ahead and set up alert first, test your application across it, make sure that your application doesn't have some weird request in it that it was seen in some other feed, and so therefore is being tracked and denied. So if you set up the alert, you can then look in the logs and see, hey, our application is actually not going to work, or we got to tweak our application before we deny it, because once you flip that deny, then it's going to be blocked. So just keep that in mind. I mentioned the availability zones only blocked it in deployment. Also outbound TCP. A lot of people sometimes run into this where if they're trying to send out SMTP traffic, it's going to be blocked by the firewall. So this is not something that's configurable. If you want to do SMTP over TLS, like the port 587, that's fine. But if you want to do just straight up clear SMTP, that's going to be blocked by the firewall. It's too common use for spam. It's not best practice anymore. You shouldn't be doing it. If you want, there are some third party tools that you can do API calls to do mass mailings. If you want to do that, there are, other relay services you can sign up for, and you can do TLS, but the amount of spam that comes across by default, outbound 25 is just blocked. And in fact, a lot of Azure services is blocked by default anyways. But the Azure Firewall, TCP 25 is blocked outbound. So don't put your generic mass mailer behind Azure Firewall if you're expecting to be able to send SMTP to resources out there. You can use SMTP TLS, which is the best practice, but if you're expecting to be able to use any old SMTP, you won't. Also, active FTP. You can use passive FTP, which is fine, but if you're going to be using active FTP, it doesn't work well with firewalls, and Azure Firewalls no different. There are sometimes ways that firewalls have gone back and configured ways to allow active FTPs to work, but Azure Firewall is not there. I'm sure that we're going to get to that point, but hey, switch to passive FTP, or maybe look at using SFTP, which again, it's a better security solution anyways. So consider looking at something else if you're using active FTP. And then the other big thing is destination NATs don't work if you're using force tunneling. Again, that force tunneling is something that we talked about before, where it, anything that's coming into your firewall, if you wanted to go through your on-premise monitoring or something, that's really something that's going to get into a particular problem that you're going to run into with destination NATs and force tunneling on the same firewall. You can have two different firewalls for those services if you need, but because of the way that you have to do default routes and the force tunneling, you can't do both destination routing and force tunneling on the same firewall. Just not going to work. All right, so it's kind of an overview of the Azure Firewall. Now, getting into Firewall Manager. Now, the Firewall Manager really works in the two last hub solutions that we talked about with Firewall. Really only works with the secured vHub, virtual hub that works with Azure Virtual WAN, and then the hub VNet. It's not designed to work with single VNets with your firewall. If you're doing single firewall VNets, you don't have a complex enough solution really to justify Firewall Manager, honestly. Firewall Manager is really designed for more complicated environments that you have a bunch of different firewalls across multiple different regions. Again, if you only have one or two firewalls, you probably don't need to have Azure Firewall Manager. Firewall Manager, again, is really designed for an enterprise type of solution, or anything that's a medium-sized business where they have multiple different regions running firewalls. So, you can look at either using the secured virtual hub, which, again, they only do one per region. So if you set up a virtual WAN and you have a hub in a particular region that you're going to make secure, if you want to use Azure Firewall, they're only going to have one virtual hub for that particular region. That should work fine for most solutions. Sometimes we run into a problem is if somebody has like a dev and prod that they want to make sure are totally isolated, even though the firewall can definitely secure that traffic. I've run into clients that they want to have a dev hub and a production hub, which is, I can appreciate their concern maybe behind that, but the firewall can deal with that traffic. If you want to set up a rule that says, nothing in dev can talk to prod, nothing in prod can talk to dev, you can put that on your secured hub, and then you can have both your prod and dev VNets talk to the same secured hub, and they'll never be able to send traffic to each other because the firewall will block all that with the secured virtual hub. So the idea is that you have only a single secured virtual hub per region, and then you have all your VNets in that region talk to that one hub. They all peered into that same hub. And then you can also do your own hub virtual networks. And again, that's where you set up the VNets, you set up the peering, you set up the routing, and you set up those pieces. And then you just have that centralized virtual hub, and then that's what's managed by the Azure Firewall Manager. And then also, there's a lot of third-party clients. Right now it's just Zscaler, Checkpoint, iBoss. There's some additional ones that are looking to get into it. But if you want to do some security as a service solutions that are out there, they can be managed directly through Azure Firewall Manager. So you're not having to, configure something here and then have to go out there to do it. And that's where we talked about, a lot of those services that can do the, not only force tunneling, but just the security as a service. And then also your centralized routes, the UDR. UDR stands for user defined routes. But the route tables, it lets you manage all your routes through one central environment. Again, that's key when you're working with firewalls. And that's something that sometimes gets kind of passed along the wayside, because once you set up a route table, a lot of times you don't monitor it or change it later. But the problem is that the route table is what defines, okay, all the packets coming into this, or coming from this particular VNet, we want to send out to the internet. It's got to go through this IP address, which is your firewall, as opposed to going straight out to the internet or going over to this other firewall and bypassing my managed firewall. And so that's where the route table is actually a really key piece to managing any firewall environment. Because if you can adjust your route table, you can set up your own routes to go whatever way you want to. The Firewall Manager makes sure that all those routes are exactly as you define them, and that you're controlling all that routing centrally through your environment. So if you have a very complex setup and different environments, and you want to have a nice, clean way to manage all your routes, the Azure Firewall Manager adds that as well when you're looking to do that. I'm not sure I'd set up a Firewall Manager just to manage your routes, but it's something that's added on if you're going to be doing it. Now, there's a policy hierarchy whenever you're dealing with the Azure Firewall Manager. Basically, you set up you set up global policies in the Azure Firewall Manager, and they will then inherit down to your Azure firewalls. The local admins could then, specify additional rules that they need locally. So, good examples, a lot of times in your prod environment, you may set up your secured vHub, and then maybe your staging environment, you still have a traditional hub VNet, so that you have a little bit more control, or you have, more dynamic environment that you're adding things, deleting them. And maybe that's what you have set up in Sage, but then your dev environment, you're going to have a lot of things where, I need to be able to test from this connection over to this connection. And so all those pieces maybe are being managed by your local policy guy, but you continue to have all your global stuff still go through standard checks, management controls, and they're being applied through your global policy, because generally speaking, with your firewall rules, it's something that you're going to expect everybody to be following in a lot of ways. In the sense of you are only going to have this traffic, from point A to point B allowed, or, only out to these particular websites. And that's usually, you don't care what environment it's in, that's that same rule that you want to have in all locations. And so that's where you're setting up your global policies, usually at the upper level, and then that's going down to your local ones. But your local ones are really only going to be, a lot of times in your dev, maybe in your staging environment, but your production usually should follow whatever your global policies are, because those should be following through a gateway, a gate control process and following a review process, and not something that's done, very quickly and agilely. You shouldn't be changing your production firewall rules a lot. So that's why, a lot of times your global policies are where you're saying those anyways. But there's no reason that you couldn't set up a local policy if you needed that for your particular environment. Everybody's sometimes they have basic needs, but as a best practice, usually if you can stick all your production in your global, then you don't have to worry about, if somebody spins up something in production in some other region, it has the exact same rules as all the other regions. Also, if you have a particular environment where you've had firewalls for a while and you've finally grown to the point where you feel like that it's now ready to bring this into Firewall Manager, and you don't have, you've grown up your rule sets, you already have all those pieces out there, but you start using Firewall Manager, you can bring all those existing rules that you had up to it into global policy, so that you can elevate all those details and see everything that's out there, and get all those particular details that you're looking for on your rules. And you don't have to go out and reprocess them, regenerate them, do a whole bunch of exports. You can just pull those directly in from them, and then you can organize those into the policies that you need on your global level. So in rule processing, basically you're just, the NAT rules get applied first, destination NATs. Then they're going to next rules that get processed are your network rules, and then they follow the idea that the parent policy gets processed first, and then the local policy, and then the application rules are follow on from behind the network rules. And again, that same process, parent policy and local policy. The rules are what they call terminating, which basically means that once a packet matches a rule, it stops. It doesn't continue looking to see, hey, does it match this one? Does it match that one? So the idea being is that if you start at the top and you have a packet that is only matched by a network policy rule, and then that way, it's going to stop immediately right there, and it's not going to travel on through any additional rules. If it's been allowed or denied here, it's not even going to be further processed. But because we are denying rules by default, if you have a packet that starts with DNAT, comes and hits network policy, and then hits the application policies, if it's never hit an allow rule, it's going to get dropped and it's going to go away. As opposed to in some environments where there's a default allow, if it goes through here and it's not been denied, then it's going to go ahead and get passed along. Well, no, in a firewall, it's going to come in, and if it doesn't match any of these rules, it's going to be denied. All right, we got a few minutes left. I'll go ahead and jump into the demo real quick here. All right, now this is just a very basic firewall rule setup area. I just set up a single VNet with a firewall in here. What's up? You see immediately what the private IP address is for the firewall. If you have a management subnet and management IP address assigned to it, that would be configured there. A lot of times that's what you use for your Azure Firewall Manager. You can also see the public IP that's been associated with it. You may click there and see what the IP address is that it's coming across as. And see what the public IP is. Just now they're getting into the DNS abilities where you can actually start doing the DNS, but again, that's in preview. Basically, you can make sure that your DNS, you're using specific DNS servers, and that you're also proxying your DNS requests. There's been a lot of more attacks coming in DNS over and over again, and so this is actually going to be a big attack vector in a lot of ways, and so that's something they're starting to work on to Azure Firewall, but still in preview. Pretty reliable, but still in preview. Anyways, the bulk of everything that you're going to be doing in Azure Firewall is within these rules. You'll see here a NAT rule already applied with an RDP client. The NAT rules are just traditional NATs. Now, once you create a NAT rule, there is an implicit network rule that is going to allow that traffic. If you're NATing something, they're assuming you want to have it. So you don't have to go in and specify an additional network rule. There's a lot of firewalls where they do have that very structured tier setup. If you want a NAT, you set a NAT. But that just does NAT. That's all it does. It doesn't allow the traffic. You then have to go in and set up the network rules to allow it. The Azure Firewall immediately allows, if you set up a NAT rule, it's going to allow that traffic. If you don't want that traffic, don't have that NAT. It's basically the mindset behind it. They're trying to simplify the management of the firewall in that instance. The NAT rule can again follow any of your standard protocol rules, the source, the IP, the destinations, all that standard stuff, standard priority rules in the environments. Your network rules, and where you do your traditional network traffics, is with the traditional, source IP, network IP, all that fun pieces, and then the internal ports, the destination ports. You can do it by service tags. So again, the traditional Azure service tags you can do in here. They're also still working in the FQDNs for the network rules. It's right now in preview, but the idea behind it is that we're going to specify a destination IP address. You can say specific FQDN, and so like if you want to allow NTP traffic, then you could put in the timeout windows and then put in 123 or whatever. You can put in those types of ideas. That's currently in preview right now. The main production pieces is doing it either by IP address or do it by service tag. Again, these are collections of rules. So the idea being is that you set up a collection and then you have several rules within it. So you would a lot of times have a particular application, whether it's it might be using web traffic for one thing, FTP traffic for something else, and maybe another piece. And so you're going to put all those different protocols together, and you can put them in one collection. That way, you don't have to worry about having to manage multiple different environments. You can just quickly see, okay, that was allowed by application A, rule. And then you also have your application rules. And this is where you get into the, what's generally considered more next generation type of firewall rules. This is the one I created just as a quick example. If you don't put this in, the clients cannot do any web browsing. If you block this off, by default, everything is going to be blocked. So if you have servers that are going to be wanting to go out and do patching, you need to make sure that traffic's allowed. You can put a network rule in that would allow access to web addresses, but a lot of times you want to do it. You may want to allow just any old web traffic. You don't really care about that particular environment. They want to browse, they can browse. But it may be that you only want to allow certain sites. So then you can put in different types of controls that way. And then you can also do the FQD and tags. Like we talked about, Windows Update is a particular tag, Azure Backups. These are a lot of the traditional Azure services that do web requests. And so that you want to be able to talk to those particular applications. And so you can just put in, hey, I want to allow Windows Update. And, I know I want to come from my internal network. I've set up my private network. There you just do that. And so you allow Windows Update. Okay. And then you just put that in. Right. Now, a collection is always going to be either all allow or all deny. So if you have a particular application where you want to allow a certain set, but you also know that there's maybe a subset in there that you don't want them to do, that's where you'd have to do both an allow and a deny rule. So just as a quick example to show you this working on a particular client, this is my client I have behind that firewall. Pull up MSDN again because of allowed web traffic, and maybe I'll go out and take a look at Google. We'll see that. Well, maybe you don't want to actually have them go out and see Google on a regular basis. So come in here and let's say block Google. We're almost done. So let's make this our value. Anybody have any questions, by the way? I know we're running low on time here. Not sure what the source is, but I want it to be HTTP or yes, and anything to Google. Yeah. And that was canceled for some reason. I was in the middle of an update. Oh, middle of the other update. Anyway, so you put in something as simple as that, where you just tell it that you want to block the that traffic, and then if somebody is to come back to that, if you don't have any cache content, I don't know if it's actually applied yet or not. Now you can see it's already blocked, but I can go to somewhere like me. So that's just a quick demo as to how the Azure Firewall knows it took effect pretty quick there, and that's again just because it's a higher priority. All right. Well, can see that we're pretty much out of time at the moment, but if anybody has any questions, again, we've gone over the Azure Networking, the Azure Firewalls, the Firewall Manager. We went through a quick demo and kind of showed about what was going on in that particular environment. Does anybody have any questions or any other additional details that they had, any information that they wanted on for the Azure Firewalls or Firewall Manager? All right. Well, Thank you very much for listening to this expert talk on Azure Firewall. My name is Kid Skinner, and this has been a presentation for the Skinning Up training. Feel free to look out in their catalog for any additional training details and let us know if you have any additional questions.